Have you ever made a mistake so fast that all you can do is frantically mash the undo key? Usually, it happens when you use a basic find and replace tool. You tell your computer to swap out one specific word for another, assuming it knows exactly what you mean. This diagram shows what actually happens. If you tell the computer to change the word cat to dog, it blindly swaps those letters everywhere. Suddenly, the word category becomes Dogegory. Traditional text search tools are dangerous because they only read individual letters. They completely ignore the context and the meaning of the words around them. Now, imagine making that exact same mistake, but inside the high-stakes world of software development. This diagram shows an active instruction telling the computer what to do, right next to a completely passive note left by a developer. A standard search tool looks at both lines, sees the same matching letters, and targets them equally. In software development, changing the wrong string of text doesn't just create a typo, it scrambles the code's structure, instantly crashing the entire application. Modern projects contain millions of lines of text, making standard search tools far too risky for bulk updates. Developers need a much smarter approach. To solve this, we have to ask a different question. What if your search tool could read the instructions the way the computer itself does? A tool called ast-grep does this by creating a structural map, essentially a grammar tree of every line of code. This map, which experts call an abstract syntax tree, acts like a teacher diagramming a sentence on a chalkboard. The tree structure takes raw text and branches out, categorizing every piece into its functional role: active commands, numbers, and plain text notes. By mapping this structure, it targets specific actions. It locks onto commands that run the program and dims everything else. By understanding the grammar of the application, the search process upgrades from a risky game of matching letters into a highly precise operation. At first glance, relying on a structural map might sound like you need to learn a complicated new language just to find a single phrase. But you command the tool using simple, plain text files. You can think of these as recipe cards for your search. Here is a recipe card in action. You can instruct the tool to find an action, but only if it receives exactly one piece of information. The tool sorts the text, keeping only snippets matching your exact rule, rejecting the rest. You can even test these recipes inside a web browser playground. This gives developers a safe visual sandbox to experiment with their search rules before running them on actual files. You don't have to write dense strings of unreadable search symbols. You simply write clear structural requests. Finding specific pieces of a massive project is highly useful. Safely replacing those pieces is where the real work gets done. With those same plain text recipe cards, ast-grep will locate thousands of outdated instructions and swap them for modern equivalents across the entire application simultaneously. A developer might spend weeks updating a task across thousands of files. This automated process cascades perfectly through the structure in seconds. Because the system understands the context of what it is reading, it operates as a high-speed editing engine for massive projects. Of course, letting an automated script rewrite your entire project all at once is a bit scary. To provide peace of mind, ast-grep uses an interactive mode, adding a mandatory human safety net to the process. This image shows how the interactive safety net works. The system pauses at every single proposed modification. It highlights the exact changes and then stops completely until a human explicitly grants permission to proceed. Developers can execute sweeping structural updates across their applications with the raw speed of automation, protected entirely by the safety of human judgment.